qualitative situation. Now, this type of data is information that is a quality or an attribute of something we're talking about. Now, we can have a category of car names. We can also have a category of car colors. Now, those are going to be what we use when we draw a pie graph. We're talking about a category, and we're going to break this category down into subcategories. But the overall circle picture is going to represent a category, and they are going to have qualitative data. And we're going to show you a little bit about it. Now, as I told you, you have a project coming up. Next week, the department should release that project. When they release that project, we can talk further, and I will explain the project once it's released. Now, you normally have a pie graph or some type of graph that you have to read or interpret or draw. Well, there are times when you're going to be having to look at a pie graph, and you are going to have to know how to interpret it. Now, couple of things if you have to make your own pie graph, or you have to be able to create a pie graph. Now, this table or this slide has a series of steps. Now, sometimes they're going to give you some of the steps and you just have to draw the pie graph. But sometimes you have to go from scratch, your project, and this is what's going to happen. You are going to have to determine a percent for the category that the circle is going to represent. And here's the key. The percent has got to add to 100%. Now, sometimes we get close, like 99 or 99.5. Well, when you have a piece left, let's say you have 99%, well, that extra 1% is known as the other part of the pie. The other part of the pie. So keep that in mind. Now, I'm going to explain this to you, but then I'm going to show you. We then have to find the measure of each sector. Now, each sector is a slice of pie, and we need the percent, which we're going to make a decimal, and then we're going to multiply by 360. And just so you remember, we're taking the sector's percent as a decimal, okay, and multiplying it by 360. Then we're going to draw each section using the central angle as a guide, and I'm going to explain that to you. Label each sector. And this is the piece that most people have trouble with when they do their project. You do not label the sector or piece of the pie with a name and a percentage. And by the way, you're going to have to give your graph, no matter what it is, a title. Now, a pie graph should be used for qualitative data only. When the categories, and here's the other catch, when the categories do not overlap and they make up one whole, which is one category. Now, quantitative data is something totally different, different types of graphs. But here, let me show you further. We're going to have the next 3 slides, and I'm going to do all the calculations for you and explain what you do. Now, the nice part about the next 2 slides is that I have already given you a completed pie graph with labels in each piece of pie, a title, and some percents. But how did we get these percents? What did we do? Okay, now, in this case, we have this particular circle. It is saying Ivan's company tracks his time spent on various tasks at work and presents him with the following monthly pie graph. Okay, over here I have it in colors. Yay! Now, assume item works fairly consistent. Now, here's the catch. 8-hour days. This pie graph is representing what Ivan does or Ian does for one day or an 8-hour shift. Now, it's asking you to determine how many hours, notice hours per day he spent on each activity. Okay, here we go. Now, this table has 3 of the 6 pieces of the graph. The second, because I wanted to make sure you see my calculations, the second part of this PowerPoint or the next slide is going to show you the last 3 parts of this circle. Now, the calculations are talking about meetings. Well, the first thing we're going to do is go to meetings. Right here. It's 19%. We are going to make 19% a decimal. And then we're going to multiply it by 8. We are going to multiply it by 8. Why 8? Because this pie chart is talking about an 8-hour day. Now, something I need to let you know. When you multiply 0.19 times 8, you are going to get the number 1.52. Now, something I need to be very clear with you with. You're going to put 1.52. Now, occasionally, because this percentage is 2 digits, sometimes you may find that they give you 1.5. These 2 digits match the number of digits that makes the percent, and the percent is 2 numbers, 19. But for our case, I'm going to leave it as a 2. Now, computers. Okay, well, let's look at computers. Now, computers are here. 31% becomes 0.31 times 8. Okay. Now, when I take my calculator and I put 0.31 times 8, I am going to get 2.48. Okay. Now, remember, 48 can be rounded off to 0.5 to 2.5. So I'm letting you know this is what I see on my calculator, but I'm going to draw a little column here because occasionally Pearson takes these hours and writes this as 1.5 and writes this as 2.5. The blue and the black are what your calculator gives you. The black is something you can see in Pearson. Now, we're going to go to calls. Calls is this part. This is 0.13 times 8. Well, again, I am going to get 1.04 on my calculator. This is my calculator. This is what you sometimes will see in Pearson. This will give me 1.0. Okay. Now, let's finish up this pie graph. Okay. Now, I have, in this particular case, the next area. Now, the next area is talking about breaks. Now, breaks, notice they wrote it out here, but it's that section of my pie chart. Now, be careful. This is 0.06 times 8. Now, this in the calculator is giving you 0.48, but I'm going to remind you that Pearson can give this as 0.5. This is in your calculator. This is Pearson. Now, lunch. Well, we already did a 13%. It was the same thing as calls. So we have 0.13 times 8. And as we learned in the calculator, it's 1.04 or just 1.0. Now, off task, again, is the same as meetings, which is 0.19 times 8. And remember, this was in my calculator, 1.52. Pearson is going to say 1.5. Now, here is something to make sure that you've done it correctly. Okay. I want to go back. Okay. Okay. Now, this 1.5, this 2.5. Now notice 1.5 plus 2.5 is 4 hours. Another hour makes 5 hours. And when I go to the rest of the chart, this 1.0 is 6 hours. Okay. It's 6 hours. And then 0.5 is 6.5 hours. And 1.5 makes it 8 hours. Okay. I need to check to see that all my hours add to 8 hours. When you get done, you've got to add to 8 hours. Now, that's why Pearson is using a rounded off portion. You are going to be slightly close to 8 hours. And let's see here. I have let's see, I've got 4. Let me go back a slide. Okay, I have 1.52, I have 2.48, I have 1.04. Okay, if you add these numbers that your calculator gives you, okay, and I'm going to put those in green. In green, if we add the green, okay, if we add the green, these green numbers will give me 8.08 hours. This is still correct. The 0.08, if I round 8.08 hours, is still 8 hours. But I want to make sure that I hit 8 hours. If you don't add to 8, go back to each row and make and correct any error that you have. Now remember, your calculator is giving you one set of numbers. Pearson is going to round them off to make life easy. Either way, whether it's the green that I got with the calculator of 8.08 hours or what I rounded to, it still gives me 8 hours, which is what this problem is doing. It's dealing with an 8-hour time frame. Now, with that said, we were given a chart. We were given the percents. Now we need to then go backwards. I'm giving you a table. You are going to have to find out the percents. Well, here we go. Now, this is saying create a circle or a pie graph. Now, this happens to have 2 parts to it. So you're going to follow the parts. Now, first thing you have to do when you create the pie chart is you must find the total of the number of subscribers. That total has to be found first because we've got to create a percent. But we're going to use a fraction to get that percent. 8 plus 11 plus 4 is 15 plus 19 is 34. You have to get this total. Now, here's how it works. You need to find the angle. Well, you're going to take 8 over 34, and you are going to get a decimal, okay? Which means when you take 8 and divide by 34, now you are going to see a long decimal of 3, 5, 2, 9, and so on. We are looking for 2 digits, which means I am going to write 0.24. Okay. Percents are going to be 2 decimals. So therefore, instead of 0.235 and so on, I'm rounding to 0.24, and then I'm going to multiply by 360. Now, when I multiply 0.24 times 360, I am getting, and I'm going to put it over here in red, my angle measure is going to be 86.4 or 86 degrees. I want a whole number here. So this 0.4 is going to kind of go away. It's less than 5. Now, that's 86 degrees. Now, sprint. Okay. I am going to take 3 divided by 34. This is going to give me let's see here, 0.09, 2 digits. I see on my calculator 0.88. That rounds to 0.9. And then I multiply 0.39 by 360. I will get 32.4, but I'm rounding it to 32 degrees. 3 divided by 34. 34 is our total. Round off this. Wanted to highlight it, not erase it. You want to make sure right here that 0.9 is the decimal. Then you give me 360. Now, we're going to do it with 4. This is 4 divided by 34. Now, this will give me 0.12 times 360, which will give me 43 degrees. You round off 0.11 because the number after that second one is bigger than 5. And then, last but not least, you are going to take 19 divided by 34. You are going to get 0.56 because your calculator is saying 0.558. That 8 is making the second 5 a 6. And then you're multiplying by 360, and you will get 202 degrees. Notice the decimal behind the 201 is a 0.6. Okay. Now, we have all the answers. Now we have to draw the graph. Well, this is where the fun part comes in. Okay. We have a center. And that center has a little black dot. Okay. Now, I normally start with the biggest one, which is 202. Now, I'm going to draw some dash lines. When you do this, use a pencil because you're going to need to do some erasing. If I put dashes straight across, notice that I've cut my circle in half. Half of 360 is 180. Well, that means I want more than 180. Well, I normally take and darken this side in. Now, those dashed lines, I know that I have to go a little bit further. Now, but the question is how much further? Well, if I take 202 and subtract 180, I'm going to get 22. That means I'm not going very far here. And I'm going to erase this. This little diagonal is saying that up here, this entire circle represents Verizon. Now remember, I've got to put a percent. This is 56%. Well, if half of the circle is 50% or 180, then I just am going 6% more. Okay, so this is my area. Now, could you use a protractor? Yes, some people do. But a pie graph is a picture. Is it extremely accurate? No. Okay. It's a picture. Now, what's my next one? My next one is the 86 degrees. Well, if I draw this dash straight down, this area here, and I'm going to make it in yellow, is a quarter of my pi, which is 1/4 or 90 degrees. Well, I have 86, which means that my dash line is really going to have to be cut a little short. This blue line and this yellow sector here is going to be A, T, and T. And remember, it's 24%. This part is going to be erased. Half of the pie is 180. Well, we had 202, little more than half. 86 is a little less than a quarter of the pie. Now, these two, notice one is 43 and one is 32. Little bit, one is a little bigger than the other. So I'm going to then make one slice of the pie a little bigger than the other. I'm going to say that this is T-Mobile, and this will give me 43%. And then this piece is going to be Sprint, which is 30. Here, get me. Sprint is 9%. And before I forget, T-Mobile, that was my decimal, my degrees. My percent for T-Mobile is 12%. I'm using this number, this number, this number, this number. Now, you see those red numbers that I circled? 24 plus 9 plus 12 plus 56. Now, they are going to add to 101. Well, we rounded off, so those percents are pretty accurate. Now, if you have a question, please always feel free to let me know so I can help you. Okay? Now, here, see what we did? See what's in the table? Now, this is a question you're going to have to watch out for because it's asking you to explain. When you explain something in Pearson, read all of your multiple choices before you pick the best choice. And here it goes. It says, explain why a pie graph is an appropriate choice for this data. Well, the data from cell phone carriers are qualitative. Also, college students make up the whole number of students asked, which is a total of 34 students who use exactly one and only one of each of the carriers, which makes a part of the category of cell phone carriers. Now, I want to make sure you understand this reply because there's certain things here that you're going to need to be aware of. Part of there. Now, the explanation has some of the vocabulary words that we talked about. The data from cell phone carriers are qualitative. So you're going to have to know what this word means. If you need to know what it means, go back and look up the definition. Also, college students make up the whole number of students asked. And this is the piece you have to know. There are 34 students only being asked. And also, who use exactly one and only one of each carrier. You're not going to have a student who has a Sprint phone and a T-Mobile phone. They're either going to be on Sprint or they're going to be on T-Mobile. They're not going to be on both. The phone that they hold is one carrier and only one carrier. And don't forget the word category. The category of this graph is cell phone providers. Okay? So therefore, you've got some words that you're going to have to watch out for. When they give you a question about explain, they are forcing you to use some vocabulary. You've got to understand the vocabulary in order to make the best choice possible. Now, this is where the next slide is still a pie graph, but this has a legend. And this is a picture that's black and white. Okay. Now, this particular picture, as you see right here, is black and white. That's going to happen. But notice I have a legend. This legend is supposedly representing the black and gray and white areas of this particular pie graph. That's why when you have a black and white pie graph, there's got to be a legend so that you can see, because in that black part of the circle, what percent is that black part of the circle? You don't know. You need this legend to help you. And knowing the legend, very easy. You may not really need this, but you do need the legend. This says the pie graph shows music recordings sold by a music store. A music store sells 5,000 recordings a month. Now, how many R&B are being sold? Well, R&B is in the legend. It's 8%. Make this 8% into a decimal. But this time, you are multiplying by 5,000 because this circle graph is representing 5,000 recordings per month. So therefore, when you take 0.08 and multiply by 5,000, you are going to get, in this case, 400 R&B recordings are sold each month. So be aware of the black and white ones. The black and white pictures have a legend. Normally you don't need the picture of the circle graph, but you do need the legend. Now with that said, let's go on to the second type of graph that we're going to be working with. This is called a bar graph. Now, it's another data display. Now, one good thing about this is that you can draw the bars horizontally or vertically. And sometimes we do have the graphs going either way. We also have the bars spaced out. If you are asked to draw a bar graph and you see spaces between the bars, that's the bar graph. But If the bars are touching, this is known as a histogram. Bars touching is a histogram. It's still a type of bar graph, but it's how it's created. So watch, if they ask you for a bar graph, don't put the bars touching each other. If they ask you for a histogram, you got to have the bars touch. So vocabulary. We're also going to let you know that bars that are placed from tallest to shortest have another vocabulary name that you are going to be seeing. This name is known as a peritograph. Peritograph. Okay. Now, this is specifically done. The bars are set up from the tallest bar going from left to right. The tallest one is the first one you're going to draw to the smallest one. And I'm going to show you a picture of it. Now, bar graphs are a useful tool when making a part-to-part comparison. Part to part. I want to compare, let's say, yellow cars and blue cars. I'm comparing them. I have a better way of comparing them than to look at a circle graph. Can I still compare them with a circle graph? Yes, but a bar graph is clearer and more distinctive than a pie graph. Now let me show you. Okay, this table again is here for you. When you do your project, you want to make sure that you do all 5 of these steps. In a bar graph, we are going to have categories. Those categories are going along the horizontal line. The categories are going along the horizontal line. Okay? And the values, which also can be known as the frequencies, are on the vertical axis. Values or frequencies, and you're going to see that when we get there. Values and frequencies are numbers. Now, we've got to draw and label the axes. Use the values to draw and label tick marks. And notice where it says on the vertical axis. Using consistent increments. If I start with 10, I go 10, 20, 30, 40, 50. I cannot go 10, 12, 27, 32, 45. I've got to have consistent increments. Then I'm going to draw vertical bars straight up and down, or I could use horizontal bars if I switch the graphs, okay, or switch the categories and the frequencies. But normally we like to draw bar graphs with the categories on the horizontal, frequencies or values on the vertical. And we're going to have tick marks on the vertical axis. But you also have to write the name of the category under the bar. Now, I'm going to give you some examples, and then we're going to do one. Now, this here, now notice, they are asking you for an example of a bar graph. Now, this graph, do you notice the bars touch? This bar graph is known as the histogram. Histogram, because the bars touch. Now, the first column in your table, right here, they are going to go along the horizontal. The frequency is going along the vertical. Now, this is something that you may not realize. You have all of these values that they gave you. See all these numbers? These numbers are placed, those numbers are placed in a frequency table because you have to sort out all of those numbers. How many 4s do I have? How many 5s do I have? How many 1s do I have? This table is known as a frequency table. I then find all of them. Now, you can also write the numbers, or something that is also done in a frequency table. You can tally the frequency and then in a separate column write the number of your tallies. So you have a couple of things to do. These are things that your book is believing that you know how to do, but I'm just clearing off the cobwebs in case you forgot. A frequency table can use tallies at first, but this table would have had 3 columns, one for the tallies and then one for the frequency or number of how many tallies I put in each row. Now, something you also want to make sure when you do your graph, make sure that you count all of those numbers I highlighted in yellow. You're going to have a certain number. If you count, I happen to have 20 numbers between the colon and the period behind that last 5. That means when I add up all of these numbers, I better get the number 20. I've got to have 20 numbers. Count them all. Do I have 20? Now, if your tally comes up like 18, you know you're missing 2 numbers or 2 pieces of data you didn't use. And then I draw the bar graph. Little details that help you make a correct table. Now, this is known, and I'm showing you what this is because some of this can be rather difficult. This is known as a Pareto chart. Now, notice as I go from left to right, I begin my first bar with the largest number. Well, notice down here I'm saying California. Well, California is $3.60. Is that the highest gas price out of these 10 states? The answer is yes. I start with the largest number. This is vocabulary. I have a table. I create this graph. Now notice, okay, all of these states are categories. Okay. And notice each state is its own entity. Unlike a pie chart, I can tell you that the highest gas prices are in California because of how the graph is drawn. And then notice, okay, what I have, okay, is right here. Gas prices. That's the second column. And notice, see the little break? That we talked about that. That little break is saying that there are no states that have gas lower than $2. It's above $2. This is the frequency or numbers. Now, my last two slides are where we're going to be doing a bar graph. Okay. And here we go. Using what we learned in Cycle 1, Section 1.7. This is one of two slides because I have two slides. This has the first question, then there is the second question. Now, it says, consider the following data on the number of fatalities from 6 most dangerous animals on the planet. Now, would you choose to present this data as a bar graph or a pie graph? Now, this is where you're going to have to watch your answer choices, okay? Because they can give you very similar answers. For this set of data, a bar graph is easier to compare the number of human deaths annually by animals. Yet, a pie graph might make it clearer what fraction of deaths of humans were done by each animal responsible for the death. Now, could I make a bar graph? Yes, it's easier. Because also, remember, in the column of number of humans, I would have to add them all together. But if you look at this, do I have every animal available in the world? Where's the lion? Where's the tiger? Where's the cougar? Where's the mountain lion? It's not there. So therefore, in this case, the bar graph would compare better. But If I knew more information, I could find fractions, and those fractions might help me understand which animal was responsible for more deaths. But I think the bar graph is better. They're going to pull in the word bar graph and pie graph. You gotta figure out and read your choices carefully. Now, let's go to the last slide. Now, this one, you gotta, again, watch your choices. It's saying, what are the challenges in making each type of graph? So notice the A part, I mentioned bar graph and pie graph. Those are the only two choices in this section. But here they're telling you you could use either one, but there are challenges. Okay. In a bar graph with vertical scales in thousands, I could have a difficult time to show the largest number of deaths and the smallest number of deaths on the same scale. Yet a pie graph would have some very small sectors, such as one sector would be about 2% and would be very hard or very tiny and hard to appreciate what the data is telling me. Okay. Now, notice what I'm looking here. I'm talking about one scale. That's the frequency. Look at all these numbers. I'm going from 750,000 to 12,000. 12,000 is a lot smaller than 750,000. So my vertical scale is not going to be as easy to create as I want it to be. Now the pie chart, I still am going to have some very small, now notice what I use the word sectors. Sectors are pieces of the pie. This small sector is about 2%. Well, where did I get that number? Remember, I added all of the numbers together and I put 12,000 over the total. 12,000 over total of this yellow column. So when they start putting numbers in there, you need to know where the numbers come from. And this would be very, and this should say tiny, I can't spell here, or type, and hard to appreciate what the data is telling me because that 2% is so small in a pie graph. But even the bars, trying to get small pieces of data when you have large pieces of data don't work. Okay. Now, hopefully these are going to help you. Okay. I'm looking forward to getting that little button, Ask Your Instructor, if you do not understand why they make certain choices of answers, especially when they ask you to explain. Because sometimes how they write an answer choice, you may think it's totally correct, but you got to really understand the vocabulary to understand, did you pick the most correct answer? Well, this is the end of section 1.7. Good luck with pie graphs and with bar graphs, and I will look forward to hearing from you if you have questions.